Hello friends, today we are going to see first part of number conversion. This is from unit number 3, number systems. That is number system. We have few types of number systems in use. Generally we use decimal number system. In decimal number system we use 10 numerals, that is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. That are your numerals. Okay, then we have binary type of number system. In binary type of number system we have something different, that is we don't have these many numerals for calculation. We have either 0 or 1, so we have only two, 0 and 1. Third type of number system is octal. In octal number system we have numerals from 0, 1, 2, 3, 4, 5, 6, 7, yes, up to 7. In all there are 8 numerals. And last one is hexadecimal. In hexadecimal we have 16 numerals: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 and A, B, C, D, E and F. So these are 4 types of number systems. In general we use decimal, but in computer programming we use binary number system. In typically in hardware systems we use hexadecimal, and sometimes we use octal also. So it is important for all of us to know the basics of all number systems and how to convert one type of number to the other type of number. And for example, from decimal to binary, from binary to decimal, from binary to hexadecimal, octal, etc. Most emphasis will be given on binary numbers because they are more widely used in computer programming. That is why we have to study binary numbers in detail. So first we will study how a binary number is represented. So first of all, we have to remember that base of a binary number is 2. In case of decimal numbers, base is 10. If you write 123 in decimal, we understand it like 100 plus 20 plus 3. So it becomes 123. Each of digit numeral in decimal has got place value and face value. Similarly, a binary number also has got a place value and its face value. So the numerals used for representing binary numbers is 0 and 1. Okay, here it is shown. Numerals is 0 and 1. So as usual, in case of decimals also we raise power of 10. First position is power 0th power of 10, then first power of 10, then second power of 10, third power of 10, etc. It goes on. Similarly in binary also we have got power of 2. So first is 0th power of 2, first power of 2, second power of 2, third power of 2, fourth power of 2, fifth power of 2 and so on. There can be nth power of 2. Then 2 to the power 0, anything raised to 0 is 1. First power of 2 is 2, second power of 2 is 4, third power of 2 is 8, fourth power of 2 is 16 and fifth power of 2 is 32. So this 2 is base, and above that row we have got power, and the result is we have the value of position. Let us consider, for example, we have a binary number 101, right? 101. So this one, okay, this one is your LSB, that stands for least significant bit, and this number is your MSB, that stands for most significant bit. The least significant bit has got least value, and MSB, that is most significant bit, has got highest value. Least significant bit, the position is 2 to the power 0, that is 1, and depending on whether we are at 4th power or 5th power, MSB will have value accordingly. In this case it is 2nd power of 2. So 101, LSB is 1, so we multiply this 1 by the 0th power of 2. Second numeral is 0, then we multiply 0 by 1st power of 2, and the last one is 1. We multiply this one by the 2nd power of 2. Each of these values are calculated individually. 2 to the power 0 multiplied by 1 is 1. 2 to the power 1 multiplied by 0 is 0, and 2 to the power 2 multiplied by 1 is 4. We add all of these individual values to get the final value. So 101 represents 4 plus 0 plus 1. So 4 plus 0 plus 1 makes it to 5. This is how any binary number is represented. Okay, so for example, if I write a number like, let us say 1011, then this one is your LSB and this one is your MSB. So this one is 2 to the power 0, so it is 1 multiplied by 1 is 1. Then this is 1 multiplied by 2 to the power 1 is 2. Then this is 0 multiplied by 2 to the power 2 is 0, and 1 multiplied by 2 to the power 3 is 8. So you will add all these numbers, 8 plus 0 plus 2 plus 1, it will be 11. Okay, likewise you can calculate any number. Okay, a binary number also offers you to represent numbers in fractions also. So you can represent numbers in fraction with the help of decimal numbers. That is also there in our syllabus. Okay, so this is all about representing a number with the help of binary number system. Now we have to convert numbers into binary and decimal format. So first we will see how to convert a decimal number into binary number. First we will see how to convert a decimal number into binary number. Here we have decimal to binary. This is an example, and the number we are going to take for conversion is 50.348. So we will make two parts of it, that is 50, and the second part is 0.348. First we will convert 50 into binary number, and then we will convert 0.348 into the other part of the binary number. Then first step is to write in this form. You write 50 in the middle of this form and divide this 50 by 2. Right, divide this 50 by 2. So the quotient will be 25. Quotient will be 25 and remainder will be 0. This R indicates remainder. Now this 25 will be divided by 2 again. You'll divide it by 12. The quotient will be 12. Divide by 2, quotient will be 12 and remainder will be 1. Similarly, divide 12 by 2, quotient will be 6, remainder will be 0. Again divide 6 by 2, you will get quotient 3, remainder 0. Then again divide 3 by 2, quotient will be 1, and it will finish. Now what you have to do is you have to note this number in this sequence from bottom to top. The number which is at bottom is called MSB and the one which is at the top is called LSB. Okay, So here one more thing, you have to copy this one as it is at this place, because you cannot divide one any further. That is why if you note this, if you note this number, it will be 1 1 0 0 1 0, right? If you note this number, it will be from bottom to top 1 1 0 0 1 0, right? So you have to write it like this type, 1 1 0 0 1 0. If you try to calculate it again, you will find that this LSB is 0, that is it makes up 0, then this one makes 2, this one makes 16, and this one makes 32. So if you add all this, 32 plus 16 plus 2 makes up 50. This is how we can confirm that your conversion is okay. So in this part we have converted 50 into its equivalent binary number. Now what we do is we will convert the fractional part into binary number. For that we have this procedure. Okay, so come down, first write the fractional part as it is. Okay, this fractional part is written here as it is, and multiply it by 2, right? Multiply it by 2, you will get this number. If this number is not greater than 1, then write 0. Okay, then write 0. So you write 0 here. Again, what you have to do is you copy this 0.696 as it is for the next iteration and multiply it by 2. Now the number is more than 1, so you will note it, or you will note it as 1. Okay, here in this case you have noted 0 because the number, that is result, was not greater than 1. Here you are noting it as 1 because the number is greater than 1. Again, take the fractional part out of 1.392, that is 0.392 for further calculation, and you will get 0.784, etc. This process will go on. You will note down 0 if the result of multiplication is not more than 1, and you will note down 1 if the multiplication is more than 1, right? And you will always consider only fractional part for multiplication, not the entire number, right? This is how you will get the number. So here what happened is we got this 0 1 in this sequence. Okay, 0 1 0 1 1 0 0. So final answer is written here. Final answer tells you two parts. First one is 50 and the second one is 0.348. Okay, this is how you have to convert any number, any decimal number, into binary number. Okay, remember the procedure. First you have to take the part which is full part, integer part, and then only fraction. Okay, here one more thing you must remember, you should note down this number in this sequence. Sorry, not in this sequence, in this sequence, in from bottom to top, from MSB to LSB. Okay, so this is how you can convert a number into you can convert a decimal number into binary number. The next one is you have to convert a binary number into decimal. The binary number for conversion is taken here. Okay, it is 101101, 0.01101. Now we are aware that this is a binary number system and you have power of 2. So I have written here, you can see the power of 2 is shown here. Okay, 2 to the power 0, 2 to the power 1, 2 to the power 3, sorry, 2 to the power 3, 2 to the power 4, 2 to the power 5. And then we will see whether 1 is present at that position or not. If 1 is present, then that power is used for finding out the answer, otherwise that power is not considered. For example, this one, this is 2 to the power 0. 2 to the power 0 is 1, and this 1 is there, so we will consider 1. Now let us consider the second digit, that is 2 to the power 2. Now 2 to the power 1. 2 to the power 1 is 2, but we don't have 1, binary 1 here, so we don't consider 2 to the power 1, right? So 2 to the power 1 is not considered, therefore 0 comes in final addition. Similarly, wherever there is 1, that power is considered. Wherever there is 0, that power is not considered. The exact values of the positions are written in the last row, 1, 4, 2, 8, 16 and 32. Okay, so the final answer for this one is 32 plus 0 plus 8 plus 4 plus 0 plus 1 is equal to 45. Okay, so if you look at MSB, it is fifth power of 2. Fifth power of 2 is 32. That is considered. Okay, fifth power of 2 is considered. Then we have third power of 2 is 8. That is also considered. Then we have second power of 2, that is 4, also considered. And the last bit that we have to consider is zeroth power of 2, and it makes 2 be 1. Add all these values, 32 plus 8 plus 4 plus 1 makes up 45. Okay, so this is how you convert the integer part of the number. Now the fractional part. For fractional part we have some other calculation. Simple it is. For fractional part we note it like the powers of in the fractional part is 2 to the power minus 1, 2 to the power minus 2, 2 to the power minus 3, 2 to the power minus 4 and 2 to the power minus 5. So 2 to the power minus 1 is 1 by 2, 2 to the power minus 2 is 1 by 4, 2 to the power minus 3 is 1 by 8, 2 to the power minus 4 is 1 by 16 and 2 to the power minus 5 is 1 by 32. So wherever there is 1, you will consider that power, otherwise you will not consider. You will add all individual values and find out the sum. So the number the binary number for conversion fractional part is 0, 1, 1, 0, 1. So the negative 1, there's a negative means 2 to the power minus 1 is not there because there is 0, so you will not consider. 2 to the power minus 2 is there, so you will consider, it is 1 by 4, so it is 0.25. Then 2 to the power minus 3 is also there, so it is 1 by 8 and 0.125 you will consider. And the last bit you have to consider in this case is 2 to the power minus 5, it is 1 by 32 and the value is 0.03125. If you add all these things together, that is 0.25 plus 0.125 plus 0.03125, the result is 0.40625. So the number 10110 dot or point 01101 gets converted into decimal as 45.40625. Thank you.